Tonight, the story of a map. A very large map, of a place nobody had ever seen, drawn by hand in a room in New York over about 20 years. It is a true story, and a calm one. There is some unfairness in it, but it is quiet unfairness, and it does not need your indignation tonight. You do not need to follow closely, or remember any of the names. If you drift off in the middle, the map still gets finished. It was finished a long time ago. Settle down, get warm, and let this go past you slowly. Marie Tharp was born in 1920, in Ypsilanti, Michigan. Her father worked for the United States Bureau of Chemistry and Soils, making soil surveys, which meant walking over farmland with instruments and then turning what he had found into maps. The work moved with the seasons, north in summer, south in winter, so the family moved constantly. By the time she finished school she had attended, by her own count, something like 24 different schools. She used to go out into the fields with her father and watch him work. She said later that she had absorbed the idea of map-making early, without ever deciding to. She went to Ohio University and took a degree in English and music, with some other subjects scattered around it, because there was no obvious career in the sciences for a woman in 1943, and everyone knew it. Then the war changed the arithmetic. With so many young men called up, the University of Michigan opened its petroleum geology program to women, because the oil industry needed people and there were not enough people. Marie Tharp applied. That is how she became a geologist. Not through a calling. Through a shortage. She took a master's degree in geology, then worked for an oil company in Tulsa, Oklahoma, where the women in the department were not permitted to do fieldwork and were largely kept to drafting and clerical tasks. She found this dull. So while she was there she quietly took a second degree, in mathematics. In 1948 she went to New York and walked into the geology department at Columbia University looking for work. She was hired to do drafting. Shortly afterwards, the department founded a new research institution up the Hudson, on an estate that had been left to the university, and it became the Lamont Geological Observatory. Its director was Maurice Ewing, an energetic and demanding man who had decided that the great unexplored territory left on the planet was the bottom of the ocean. At Lamont, Marie Tharp was assigned to work with a graduate student named Bruce Heesen. That partnership lasted more than 25 years. It produced most of what we know about the shape of the seafloor, and it was, by all accounts, argumentative, close, and not always generous in the way credit was shared. Here is the practical problem they faced. In 1948, nobody had any real idea what the bottom of the ocean looked like. The general assumption was that it was more or less flat. A vast plain of mud, gently sloping, with a few isolated seamounts, and nothing much happening. The ocean was thought of as a lid on a boring floor. The instrument that changed this was the echo sounder. A ship sends a pulse of sound downwards, and listens for it to come back off the bottom, and the time it takes tells you the depth. Ships had begun carrying these during the war, for submarine detection, and they recorded continuously as they steamed along. So each crossing of the Atlantic produced a strip of paper, a long unbroken profile of the depth beneath the ship's track. Lamont's vessels went out and gathered these by the mile. They came back with rolls and rolls of paper. And on its own, one profile is nearly meaningless. It is a squiggle. What was needed was somebody who would take hundreds of squiggles and turn them into a landscape. That was the job Marie Tharp was given, and there is a detail about it that has to be said plainly. She was not allowed on the ships. Women were not permitted aboard the Lamont research vessels. The reasons given were a mixture of tradition, superstition about women at sea, and vague remarks about accommodation and morale. So the arrangement was this. Bruce Heesen and the others went out for weeks at a time and collected the soundings. Marie Tharp stayed in the building and turned them into geography. She did not set foot on a research ship for the first 17 years of the work. She finally went to sea in 1965. By then she had already drawn the Atlantic. It is worth pausing on how odd that is. The person who produced the first real picture of the floor of the Atlantic Ocean had, at the time she produced it, never been out over the deep water at all. She built it entirely out of other people's measurements, on sheets of paper, at a desk, in a room. The method was slow and it was all done by hand. She would take each ship's track and plot its position, then read depths off the echo sounder record and convert them into a profile drawn to scale. Then she would lay the profiles out in their correct geographical places, and begin the difficult part, which was working out what must lie between them. The tracks were far apart. Whole regions had only 1 or 2 crossings. Filling the gaps required judgment about how underwater landforms behave, built up from experience of what the profiles kept showing. She then drew the result not as a contour map but as a physiographic diagram. That is, a picture of the terrain as though you were looking at it from an angle, in a bleak view, with the mountains shaded as mountains. This was a deliberate choice. Contour lines are precise and almost nobody can read them intuitively. A shaded landscape can be understood by anyone in a second. It also, importantly, sidestepped a rule of the time. Detailed contour charts of the ocean floor were considered militarily sensitive, useful to submarines. A landscape drawing was not. In 1952 she had 6 profiles of the North Atlantic laid out, running roughly east to west. And she noticed something. Down the middle of the ocean there was a great ridge, a range of mountains running north to south, which was already known in a rough way. But in her profiles, right at the top of that ridge, there was a notch. A V-shaped valley, cut into the crest, deep and narrow. And it appeared in all 6 profiles, in about the same place, thousands of miles apart. She checked, and redrew, and checked again. It was not a slip of the pen. There was a continuous rift valley running down the center of the mid-ocean ridge, like a crack. She showed it to Bruce Heesen. He was not pleased. If there was a rift, something was pulling the ocean floor apart, and that meant continental drift, which in 1952 was a thoroughly disreputable idea in American geology, associated with cranks. By her own later account, he told her it was girl talk, and told her to do the work again. That phrase comes to us from her recollection, written down decades afterwards. It is her memory of the moment. We have only her word for the exact words. She did the work again. It came out the same. And then something happened that settled it, and it is my favorite part of the whole story, because it involves 2 people working on completely different problems and not comparing notes until the end. In the same office, a colleague named Howard Foster had been given a separate task. He was plotting the locations of earthquake epicenters in the ocean, for a project on where it was safe to lay transatlantic telephone cables. He had produced a map of dots, each one an earthquake. Somebody laid his map of dots over her map of the ridge. The earthquakes ran in a line down the middle of the ocean. Not near the ridge. Along the rift valley she had drawn, right inside it, following its bends. 2 entirely independent kinds of evidence, collected for 2 unrelated reasons, describing the same feature. That is about as good as evidence gets in the earth sciences. Heesen stopped arguing. From then on he defended the rift as vigorously as he had dismissed it, which is, to be fair, how science is supposed to work, even when the person who was right does not get much said about it. The idea took another decade to be generally accepted, and Tharp and Heesen were attacked for it in the meantime. Jacques Cousteau, so the story goes, set out to disprove the rift and towed a camera across the ridge to show there was nothing there, and filmed the valley instead. That anecdote is repeated often and the details vary in the telling, so treat it lightly. What is solid is the sequence of the argument. Through the 1960s, the pieces arrived. Harry Hess proposed that new ocean floor was being made at the ridges and spreading outwards. Then came the magnetic stripes, symmetrical bands of alternating magnetism in the rock on either side of the ridge, matching each other like a mirror, which is very hard to explain by any means other than the seafloor growing outward from the center. By the end of the decade, the theory of plate tectonics was established, and the old objection to continental drift, that there was no mechanism, had an answer. The continents do not plow through the ocean floor. They ride on it, and the ocean floor is being made and destroyed. The rift Marie Tharp found is where it is made. Here is the thing I did not know until I read about her, and it still seems slightly unreasonable. The mid-ocean ridge system is not just an Atlantic feature. It is continuous. It runs down the middle of the Atlantic, around the bottom of Africa, up into the Indian Ocean, out across the Pacific, and on, joined up, for something like 40,000 miles. It is by a very long way the largest mountain range on Earth. It is bigger than the Andes, the Rockies, the Alps and the Himalayas put together, several times over. It covers a substantial fraction of the surface of the planet. And in 1950, essentially nobody knew it was there, because it is under 2 miles of water. It was drawn, first, in a room, on paper, by a woman who was not permitted to visit it. Tharp and Heesen published their map of the North Atlantic in 1957. Then the South Atlantic. Then the Indian Ocean. Then, working with an Austrian landscape painter named Heinrich Baran, the whole world ocean floor, in color, as a single panorama, published in 1977. Bruce Heesen died that same year, at sea, aboard a submarine off Iceland. She finished the map without him. The 1977 world map is still the image most of us carry in our heads when we imagine the bottom of the ocean. It hung in classrooms and offices for decades. It is not, strictly, an accurate survey. Much of it is informed inference, filling gaps between sparse ship tracks with a trained sense of what the terrain does. Modern satellite gravity data and multi-beam sonar have refined it, and moved things about, and corrected her in places. What is remarkable is how little they have had to correct. Marie Tharp kept working, mostly quietly, and mostly without much recognition, for a long while. In her later years the recognition arrived. The Library of Congress named her one of the great cartographers of the 20th century. She was given medals by societies that had once not admitted women. She lived until 2006. When people asked her about the years of being told she was wrong, and being kept off the ships, she was, by most accounts, wry rather than bitter about it. She said she had been given a blank sheet of paper and the whole ocean floor to put on it, and that this was not a bad way to spend a working life. So picture that room. A desk, a lamp, long strips of paper covered in a wobbling line, and a woman drawing mountains she will not see for another 17 years. Beneath her, somewhere far off and very dark, the ridge goes on doing what it does. Slowly. A few centimeters a year. Making new ground, and pushing the continents a little further apart while everyone sleeps. There is another story waiting whenever you want it. Rest now. Good night.